Let's look at the forces acting on this mass attached to a spring. There is the weight force down, and a tension force from the spring up. There is no net force on this mass, the forces are balanced, and it is at its equilibrium position. The equilibrium point is where an oscillating system would eventually come to rest. If the mass is moved from the equilibrium position, then it experiences a force from the spring, given by Hooke's law. If we now release the mass, then it will move back up to the equilibrium position. Because of its momentum, it will move past the equilibrium until it reaches its highest point. At its highest point, the spring force pushes it back down again. In an oscillator, the force that acts to restore the system to its equilibrium point is called the restoring force. In this case it is the spring force. If the spring were perfect, and there were no air resistance, then the spring would bounce forever. In real life, the oscillations are damped, meaning that the amplitude of oscillation will become smaller and it will eventually come to rest in its equilibrium position.